In this lecture we'll answer two questions. In the first question, we'll find out the area of this square ABCD. In the second question, we'll find out the size of this angle theta, that is inside triangle DOE. We'll start with the first question. In the drawing, we have square ABCD. Know that line segment AP equals to 5 units in its length, line segment PB equals to 3 units, and finally line segment PC is equal to 6 units in its length. And our mission is to find out the area of this square ABCD. So first of all, we'll do a construction. We'll extend side C, DC of this square ABCD by a straight line. And from point P, we'll go perpendicular on the extended side DC. So actually, this angle is equal to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point P in the extended DC as N. In the next step, we will do another construction from point B. We will do perpendicular on PN. Again, from point B, we will do perpendicular. We will draw a perpendicular on PN. So here, this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and PN as M. We define side BM as A. Here, side BM equals to A units according to our definition. We define side PM as B. Here PM equals to B units according to our definition. In the next step, we will implement the Pythagoras theorem on the right green triangle PBM. So, the right green triangle PBM, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PBM, the right green triangle, the hypotenuse is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to BM squared plus PM square. Repeat again. According to the Pythagoras theorem in the right green triangle, triangle PBM, PB square equals to BM square plus PM square. Okay, so here PB equals to 3 units, therefore PB square is 3 squared, that is 9. And it is equal to BM square. BM is 8, therefore BM square will be equal to A square plus PM square. PM equals to B, therefore PM square will be equal to B square. So, in conclusion, we found out that according to equation number 1, A square plus B square equals to 9. We know that all the angles inside a square are right angles. So in square ABCD we have 4 right angles. Those 4 angles are right angles in square ABCD, and DC is one side of square ABCD, therefore it is absolutely a straight line. DC is a straight line. When we extended the straight line DC by a straight line, the result is DN. So when you extend a straight line by a straight line, the result, that is DN, must be also a straight line. So you can write down that DN, line segment DN, is a straight line. Line segment DN is a straight line because when you extend a straight line by a straight line, the result must be a straight line. DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DN at point C? We have this angle that is equal to 90 degrees plus this angle that is the missing angle. In total, the sum of those 2 angles must be equal to 180 degrees. So 90 degrees plus the missing angle must be equal to 180 degrees. So the missing angle must be equal to 90 degrees also. In order to complete the sum of the angles in the upper side of DN at point C to 180 degrees, the missing angle must be also equal to 90 degrees. So inside quadrilateral BMCN, inside this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in quadrilateral BMCN to 360 degrees. The fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here inside quadrilateral BMCN we have 4 right angles, therefore quadrilateral BMCN is a rectangle. Okay. So here we will focus on the lower side of line segment AN at point B. On the lower side of AM at point B, this angle equals to 90 degrees, and this angle it is also equals to 90 degrees. Therefore, angle ABM equals to 180 degrees. So I write it down that angle ABM is equal to 180 degrees. Any angle that is equal to 180 degrees, it is a straight line. Therefore, angle ABM is a straight line. If angle ABM is a straight line, it means that line segment ABM is a straight line, and if line segment ABM is a straight line, it means that AM is also a straight line. Okay, AM is a straight line. AM is a straight line. AM is a straight line. So, if AM is a straight line, it means that shape APM, this shape is a right triangle. Okay? Therefore, we'll implement the Pythagoras theorem on the right green triangle, triangle APM. Okay? Here by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, the right triangle APM, AP square equals to PM square plus AM square. And repeat again, in the right green triangle APM, according to the Pythagoras theorem, AP square equals to PM square plus AM square. Okay, so the hypotenuse AP equals to 5 units. According to what is given as a question, therefore AP square is 5 square, that is 25. And it is equal to PM square. PM equals to B, therefore PM square is B square. Plus AM square. We define the side length of square ABCD as X. Therefore, all of its sides will be equal to X units in their lengths. So, what is the length of side AM? The length of side AM, it is very easy to say from the drawing that AM equals to X plus A. AM equals to X plus A, therefore AM square will be equal to X plus A square. So, in conclusion, we found out that according to equation number 2, 25 equals to B square plus X plus A square. Here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, 25 equals to b squared plus x plus a squared. X plus a squared equals to x squared plus a squared plus 2 times ax. So here, inside equation number 2, we have a squared plus b squared. And we know that according to equation number 1 here, a squared plus b squared equals to 9. Therefore, we substitute a squared plus b squared in this equation number 2 by 9. We'll do it now. We'll get that 25 equals to a squared plus b squared is 9 plus x squared plus 2ax. Here we subtract 9 from this equation number 2, and we get that according to equation number 2, 25 minus 9 is 16. That is equal to x squared plus 2ax. Here we subtract x squared from this equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation number 2 by 2x, and we get that according to equation number 2, 16 minus x squared over 2x equals to a. We found out the value of a in terms of x. Okay. We have already found out that inside quadrilateral BMCN we have 4 right angles, therefore quadrilateral BMCN is a rectangle. So I write it down. Quadrilateral BMCN is a rectangle because it has 4 right angles. Okay, but we know that the opposite sides, we also know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN. But according to our definition, BM equals to A, so we can write it that BM equals to A. And from this equation, A equals to BM equals to Cn, we will derive that Cn is also equals to A. Cn equals to A. You can write here that Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to MN. BC equals to MN. But BC equals to X according to our definition. So we can write here that BC equals to X. And from this equation, X equals to BC equals to MN, we will derive that MN is also equals to X. MN equals to X. MN equals to x. Here mn equals to x. In the next step, we will implement the Pythagoras theorem on the right big triangle, triangle PCN. Repeat again, we will implement the Pythagoras theorem on this right big triangle, triangle PCN. So, in the right big triangle, triangle PCN, by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, the hypotenuse of the right triangle PCN is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to Pn squared plus Cn squared. I'll repeat again, in the right triangle, triangle PCN, according to the Pythagoras theorem, we get that PC squared equals to Pn squared plus Cn squared. According to what is given on the question, PC equals to 6, therefore PC squared is 6 squared, it is 36, and it is equal to Pn squared. What is the value of Pn? It's very easy to see from the drawing that Pn equals to b plus x. Therefore Pn squared is b plus x squared. Plus Cn squared. Cn is 8, therefore Cn squared is 8 squared. So in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we open the brackets of this side of equation number 3 and we get that according to equation number 3, equals to b plus x squared is b squared plus x squared plus 2bx plus a squared. So here we have a squared plus b squared in equation number 3, therefore we will substitute a squared plus b squared by 9 because it is equal to 9 according to equation number 1. We'll do it now and get that according to equation number 3, 36 equals to a squared plus b squared is 9 plus x squared plus 2bx. Here we subtract 9 from this equation, equation number 3, and we get that according to equation number 3, 36 minus 9 is 27, that is equal to x squared plus 2bx. Here we subtract x squared from this equation, equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. Here we divide this equation, equation number 3 by 2x, and we get that according to equation number 3, 27 minus x squared over 2x equals to b. So we found the value of b in terms of x. And we already found out the value of a also in terms of x. And according to equation number 1, we have already found out that a squared plus b squared equals to 9. We have already found out that a equals to 16 minus x squared over 2x. Here we'll square a in order to get the value of a squared. Plus b squared. We already found out that b is equal to 27 minus x squared over 2x. We will square this expression in order to get the value of b squared. And according to this equation, equation number 1, this is equal to 9. So here we'll open the brackets on those two expressions. And we will get that according to this equation, equation number 1, 16 minus x squared equals to 16 squared, that is 256, plus x squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And here the denominator of those two expressions is equal to each other, so it's the same. It is equal to 4 times x squared. Therefore we'll add the numerator of this expression to the numerator of this expression because they have the same denominator. And we get that here 27 minus x squared is equal to 27 squared, that is 729, plus x squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared. All divided by 4x squared, it is equal to 9. So here 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is equal to 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared. All divided by 4x squared is equal to 9. So here we multiply this equation number 1 by 4x squared. And we get that according to equation number 1, 2 times x to the power of 4 minus 86x squared plus 985 is equal to 9 times minus 4x squared is 9 times 4x squared is equal to 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 is equal to 0. We will define z as x squared, that is to say z equals to x squared according to our definition. If z equals to x squared, it means that the z squared equals to x to the power of 4. So this expression in total will be equal to 2z squared and we have here minus 122 x squared. X squared is z according to our definition, therefore we substitute x squared in this equation number 1 by z. Again, minus 122z plus 985 is equal to 0. So we have here a quadratic equation, 2z squared minus 122z plus 985 equals to 0. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here in this general formula for quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay. In our specific quadratic equation, the coefficient a equals to 2 units, the coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z. So those are the coefficients of our specific quadratic equation. So we'll put the data inside the formula for x, and we'll find out the value of the values of z, because x equals to z in our specific quadratic equation. So here we get that z equals to minus b. B is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a. Minus 4 times a is minus 4 times 2, that is minus 8, times c is 985. So minus 8 times 985 is minus 7,880, all divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So Z equals to 122 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004 over 4. So Z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4. So here we will have two solutions for Z. The first solution for Z will be 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that Z equals to 51.4224 check that I'm not wrong. 205 over, it is 205.6899 over 4. Two hundred 5.6899 over 4 is equal to 51.4224. So we found out that Z that is equal to x squared according to our definition is equal to 51.4224. Here we take a root out of this number in order to get the value of x itself. And we get that x itself equals to the square root of this number, that is 7.17 units. So we found out that x equals to 7.17 units, and it is impossible that AB that is equal to x will be equal to 7.17 units. I will explain you why. Because if you focus on the right triangle APM, the hypotenuse is AP, that is the biggest side in any right triangle. So AP is the biggest side of the right triangle APM, that is to say AP that is equal to 5 units is bigger than AM. If AP is bigger than AM, let alone that AP will be bigger than AB. So we know that AP that is equal to 5 units is bigger than AB that is equal to x. So I'll write it down here. AP in the right triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB, that is equal to X. So from this inequality, we'll get that X is less than 5 units. X is less than 5 units, but we just right now found out that X is equal to 7.17 units, that is bigger than 5 units. So we have a contradiction, and due to the contradiction, we cancel the possibility that Z is equal to 51.4224. Due to the contradiction, we cancel this possibility, and we left only in the second solution to the quadratic equation. According to the second solution, Z equals to 122 minus 83.6899 over 4, and 122 minus 83.6899 is equal to 38.3103, and if we divide it by 4, we will get that Z is equal to 9.5775. Okay, but what is Z? Z, according to our definition, equals to X squared, and we found out that Z equals to 9.5775. But what is the area of square ABCD? The area of square ABCD equals to X squared. You can see it from the drawing. The area of square ABCD equals to X squared. Therefore, we actually found out that the area of square ABCD, that is equal to X squared, that is equal to Z, it is equal to 9.5775 square units. So here, if we take root from this number, we get the value of X. The root of this number will give us the value of X. Here we found out that the value of X is 3.09 units, and here you can see that X is smaller than the hypotenuse AP, that is equal to 5 units. Therefore, this is the correct answer. Finally, we found out that the area of square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle, triangle ABC. Angle ABC equals to 90 degrees. Inside triangle ABC, we have a circle. Inside the circle, we have triangle DOE. And our mission is to find out the size of this angle theta. Okay, it is given us the question that line segment AD equals to line segment EC. And we also know that DE is twice as long as AD, and DE is also twice as long as EC. That is to say, AD equals to EC equals to DE over 2. Okay, so here we will define DE as 2A. Here, DE equals to 2A according to our definition. And according to what is given as the question, we know that AD equals to EC equals to DE over 2. But according to our definition, DE equals to 2A, so we substitute DE by 2A. So here 2A over 2 is A. So in conclusion, we found out that AD equals to EC, that is equal to A. Okay, is equal to A. That is to say, AD is equal to A, and EC is also equals to A. In the next step, I will present to you rule number 4, and we will implement rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisects the chord. The center of the circle is at point O, the perpendicular OM to the chord CD bisects chord CD. That is to say, according to rule number 4, CM equals to MD. And so the chord CD has been bisected into two halves. The first half is CD over 2, that is equal to CM, and the second half it is also CD over 2, that is equal to MD. We can implement rule number 4 in our drawing. The center of the circle is point O, so from point O we will go perpendicular on chord DE. So this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord DE as T. So here, according to rule number 4, perpendicular OT bisects chord DE, that is to say DT is equal to TE, and the chord DE has been bisected into two halves. Each half equals to DE over 2. So TE equals to DE over 2, and DT is also equals to DE over 2, according to rule number 4. According to our definition, DE equals to 2A, so we substitute DE by 2A over 2. 2A over 2 is A. So in conclusion, we found out that DT equals to TE, and they are both equal to A. Okay, so DT equals to A, and TE is also equals to A, according to what we just right now found out. Here DT equals to TE equals to A. In the next step, we'll define the point of tendency of tangent AB in the circle as M. We'll define the point of tendency of tangent BC with this circle as N. We'll join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of this circle that we define as capital R. So OM equals to capital R. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Again, point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circle that is equal to capital R. Again, we have the radius ON that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. And this angle will be also equal to 90 degrees. So inside quadrilateral OMBN, this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be equal also to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral MOBN, we have 4 right angles. Therefore, quadrilateral MOBN is a rectangle. I'll write it down. Quadrilateral MOBN that has 4 right angles is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN, but we already found out that MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. BN is also equals to R. Here, BN equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that ON equals to MB. ON equals to MB. But ON equals to R, according to what we have already found out. And from this equation, R equals to, from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. MB equals to R. MB equals to R. So we actually found out that quadrilateral MOBN is not a rectangle but a square because of the fact that all of its sides are equal to each other, they are equal to R. So we can write down that quadrilateral MOBN is a square. Okay, so in the next step, I will present to you a new rule and we will implement the new rule in our drawing. Here we have rule number 10. According to rule number 10, if we have this circle and we have the external point P, from the external point P we have tangent PA is tangent to this circle at point A. Then we have the straight line here that intersects with this circle at points B and C. So if this is the data that has been given to us, then the following equation is true, that PA square equals to PB times PC. Again, PA square equals to PB times PC. Okay, we can implement rule number 10 in our drawing. So here we will focus on the extra point C. From the extra point C, we have tangent CN to this circle, and we have the straight line here that intersects with the circle points E and C. Therefore, according to rule number 10, we get that CN squared equals to CE times CD. Again, CN squared CN squared equals to CE times CD. So this equation is the implementation of rule number 10 at point C. CN squared equals to CE times CD. So here, so CN squared equals to CE. CE is A, so we substitute CE by A times CD. CD, what is the value of CD? CD equals to A plus A plus A, that is 3A. So we substitute CD by 3A. So in conclusion, we found out that according to rule number 10, Cn squared equals to A plus 3A. So Cn squared equals to A plus 3A is 3A squared. Here we take a root out of this equation and we get that Cn equals to the square root of 3A squared. The square root of 3A squared, the square root of 3A squared is 8, the square root of 3 is the square root of 3. So in total we found out that the square root of 3A squared is square root of 3 times A. Okay, we found out that Ca equals to square root of 3 times A. And write here that Cn equals to the square root of 3 times A. In the next step, we'll focus on the extra point A. On the extra point A, according to rule number 10, first of all, you can see here that we have tangent AM, and from point A we have this straight line that intersects with the circle at points D and E. That is the reason that we can implement here rule number 10. According to rule number 10, we will get that AM squared equals to AD times AE. Repeat again. If you focus on the extra point A, according to rule number 10, we get that AM squared equals to AD times AE. So here, so AM squared equals to AD. AD is A, so we substitute AD by A times AE. What is the value of AE? It is very easy to see from the drawing that AE equals to A plus A plus A, that is 3A, so we substitute AE by 3A. So in conclusion, we found out that AM squared equals to A times 3A. A times 3a is 3a squared. We'll take a root out of this equation and we get that AM equals to the square root of 3 times A. So we found out that AM equals to the square root of 3 times A. In the next step, I will copy the right triangle ABC in a new page and we'll analyze triangle ABC. What is the length of the hypotenuse AC? The length of the hypotenuse AC equals to A plus A plus A plus A, that is 4A. What is the length of side AB of triangle ABC? It is very easy to see from the drawing that the length of side AB equals to square root of 3 times A plus R. What is the length of side BC of triangle ABC? It is equal to square root of 3 times A plus R also. So this is the right triangle ABC that I copied from the original drawing. Side AB equals to square root of 3 times A plus R, and side BC also equals to square root of 3 times A plus R. So those two sides, they are equal to each other, and we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because of the fact that those two angles are equal to each other according to the rule that I mentioned. And we know that this is a right angle, therefore this angle equals to 90 degrees, therefore the rest angles, those two angles must be equal to 90 degrees. Why? Because 90 degrees plus 90 degrees is 180 degrees. So in order to complete the sum of the angles in this right angle to 180 degrees, those two angles must be equal to 90 degrees in total. So we found out that here alpha plus alpha, the sum of those two angles in total, must be equal to 90 degrees. Alpha plus alpha equals to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divide this equation by 2 and we get that angle alpha equals to 90 degrees over 2, that is 45 degrees. So we found out that the angle alpha equals to 45 degrees. So those two angles are equal to 45 degrees each. So in the next step, we focus on the right triangle ABC, in the right triangle ABC. It is very easy to see from the drawing that if we focus on this angle, cosine 45 degrees is equal to BC over AC. Okay, cosine 45 degrees equals to BC over AC. So BC equals to square root of 3 times A plus R. AC equals to 4A. And cosine 45 degrees is 1 over square root of 2, that is equal to square root of 3 times A plus R over 4A. Here we will multiply this equation by square root of 2. We'll multiply this equation by 4a, and we get that according to this equation, 4a over square root of 2 equals to square root of 3 times a plus r. So here we'll substitute 4 by 2 times 2, and we'll get that 2 times 2 times a over square root of 2 equals to square root of 3 times a plus r. So here we substitute one of the 2's by square root of 2 times square root of 2, and we get that 2 times 2, and 2 is square root of 2 times square root of 2 over square root of 2 times a equals to square root of 3 times a plus r. Okay, so we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And finally we found out that 2 times square root of 2 times a equals to square root of 3 times a plus r. Here we subtract square root of 2 times a from this equation, and we get that 2 times square root of 2 times a minus square root of 3 times a equals to r. So here we take a as a common factor, out of those two expressions. So a is a common factor. What is left from 2 times square root of 2 times a, after from it a is a common factor? What is left is 2 times square root of 2. And what is left from minus square root of 3 a, after we took from it a is a common factor? What is left is actually minus square root of 3, that is equal to r. So in conclusion, we found out that r equals to a times 2 times square root of 2 minus square root of 3. Okay, so in the next step I will copy the right triangle DOT in the new page, and we'll analyze triangle DOT. Here point O is the center of the circle, point D is the point of the circle itself, therefore DO is the radius of the circle, that is equal to 1. So actually this is the right triangle DOT, is a copy from the original drawing. In this right triangle DOT, it is very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Okay, so I write it down. So cosine theta equals to dt over do. dt equals to a, so we substitute dt by a over do. do equals to r, so we substitute do by r. So in conclusion, we found out that cosine theta equals to a over r. And repeat again, we found out that cosine theta equals to a over r in the right triangle, triangle DOT. But we already found out that r equals to a times 2 times square root of 2 minus square root of 3, so we substitute r by a times 2 times square root of 2 minus square root of 3, and we get that cosine theta equals to a, and r equals to a times 2 times square root of 2 minus square root of 3. So here we have a in the numerator and we have a in the denominator, so a will get cancelled. A will get cancelled, and we're left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. Therefore, we will operate the opposite function of cosine, that is cosine minus 1 on the result here, in order to find out the value of theta itself. So, the opposite function of cosine is cosine minus 1. We will operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3. And we get the value of theta itself. Okay? So when you operate the opposite function of cosine on this expression, you will get that the value of theta is equal to 24.203 degrees. So we actually found out that the value of angle, the size of angle theta is 24.203 degrees. Here, the size of this angle theta is equal to 24.203 degrees. We finished with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. In the drawing, we have square ABCD. We know that line segment AP equals to 5 units, line segment BP equals to 3 units, and finally line segment CP equals to 6 units. And our mission is to find out the area of this square ABCD. So first of all, we did the construction. We extended side DC of square ABCD by a straight line. And from point P, we do perpendicular of the extended DC. So this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point P, and the extended DC is N. Then we did another construction from point B. We drew perpendicular on PN. Again, from point B, we drew perpendicular on PN. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Okay, then we define side PM as B, and we define side BM as A. Then we implemented the Pythagoras theorem on the right green triangle, triangle PBM. According to the Pythagoras theorem, PB square equals to PM square plus BM square, or PB square equals to BM square plus PM square. In the right triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to BM square plus PM square. According to what is given as the equation, PM equals to 3, therefore PM square is 3 squared, that is 9. And it is equal to BM square. BM equals to 8, therefore BM square is A square plus PM square. PM is B, therefore PM square is B square. So in conclusion, found out that according to equation number 1 and Pythagoras theorem, 9 equals to A square plus B square. We also know that all the angles inside a square are right angles, so those 4 angles are right angles in square ABCD. Then, when we extended side DC, first of all, DC is one side of square ABCD, therefore it is absolutely a straight line. So when we extended the straight line DC by straight line, we got DN. When you extend a straight line by straight line, the result is straight line. Must be a straight line. So DN must be a straight line. DN is a straight line. So if you focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side? On the upper side of DN at point C, we have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this angle must be also equal to 90 degrees in order to complete the sum of the angles on the upper side of DN at point C to 180 degrees. This angle must be equal to 90 degrees. Okay, so inside quadrilateral BMCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. This angle must be equal to 90 degrees. Therefore, quadrilateral BMCN has 4 right angles. Therefore, quadrilateral BMCN, that those 4 right angles must be, it is a rectangle. Okay, quadrilateral BMCN with 4 right angles is a rectangle. Okay, and here we focused on the lower side of segment line AM at point B. This angle equals to 90 degrees and this angle equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. So angle ABM equals to 180 degrees. If angle ABM equals to 90 degrees, then angle ABM must be a straight line. If angle ABM is a straight line, then line segment ABM is a straight line. If line segment ABM is a straight line, line segment AM is also a straight line. Line segment AM is a straight line. And if line segment AM is a straight line, then shape APM, this shape APM must be a right triangle. Okay? So if APM is a right triangle, we implement the Pythagoras theorem on the right triangle, triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus AM square. In the right triangle, triangle APM, AP square equals to PM square plus AM square. Here AP equals to 5, therefore AP square is 5 squared, that is 25. PM equals to B, therefore PM square is B square. AM equals to X plus A, therefore AM square is X plus A square. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus X plus A square. We open the brackets on this end of equation number 2 and found out that 25 equals to B square plus X plus A square equals to X square plus A square plus 2 times AX. We have already found out that according to equation number 1, A square plus B square equals to 9. Therefore, we can substitute A square plus B square in equation number 2 by 9. We did it when we got that 25 equals to 9 plus X square plus A square. Here we subtracted 9 from this equation and found out that 25 minus 9 is 16. That is equal to X square plus 2A square. Here we subtracted X square from this equation number 2 and found out that 16 equals to X square minus X square plus 16 minus X square equals to 2AX. Here we divided this equation number 2 by 2x and found out that 16 minus X square over 2x equals to A. So we got the value of A in terms of X. Then quadrilateral BMCN that those 4 right angles is a rectangle. Repeat again, quadrilateral BMCN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say BM equals to CN. But CN equals to A. And from this equation, A equals to BM equals to CN. We will derive that Cn is also equals to A. Here Cn is also equals to A. Likewise, according to the sum rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to Mn. BC equals to Mn, but BC equals to X according to our definition. So from this equation, X equals to BC equals to Mn, we will derive that Mn is also equals to X. Here Mn equals to X. Then we implemented the Pythagoras theorem on the right green triangle PCN. According to the Pythagoras theorem on the right green triangle PCN, PC square equals to Pn square plus Cn square. PC square equals to Pn square plus Cn square. So PC equals to 6, therefore PC square is 6 squared, that is 36. And it is equal to Pn square. Pn is B plus X, therefore Pn square is B plus X square plus Cn square. Cn is A, so Cn square is A square. So in conclusion, found out that according to equation number 3, 36 equals to B plus X square plus A square. Here we open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to B plus X square equals to B square plus X square plus 2BX plus A square. Here we have in equation number 3 B square plus A square. So we can substitute B square plus A square by 9, because according to equation number 1, A square plus B square equals to 9. We did it when we got that 36 equals to 9 plus X square plus 2BX. Here we subtracted 9 from this equation number 3 and found out that 36 minus 9 is 27. So 27 equals to X square plus 2BX. Here we subtracted X square from this equation number 3 and found out that 27 minus X square equals to 2BX. Here we divided this equation number 3 by 2x and found out that 27 minus x squared over 2x equals 2b. So we got the value of a and b in terms of x. Then we have equation number 1. According to equation number 1, we found out that according to equation number 1, a squared plus b squared equals to 9. And we have only found out that a equals to 16 minus x squared over 2x. So if we square this expression, we got the value of a squared. We already found out that b equals to 27 minus x squared over 2x. So if we square this expression, we get the value of b squared. So a squared plus b squared equals to 9 according to this equation number 1. We open the brackets of those two expressions. In equation number 1, we found out that 16 minus x squared equals to 16 squared, that is 256, plus x squared is x to the power of 4, minus 2 times 16 is minus 32, so this expression equals to minus 32x squared in total. And because of the fact then those two expressions have the same denominator. We can add the numerator of this expression to the numerator of this expression. We did it, and we got that 27 minus x squared equals to 27 squared, that is 729, plus x squared is x to the power of 4, minus 2 times 27, that is minus 54, times x squared. All divided by 4x squared equals to 9. Here, 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. And here, minus 32x squared minus 54x squared is minus 86x squared, divided by 4x squared equals to 9. We multiply this equation number 1 by 4x squared, and found out that 2x squared minus 86x squared plus 985 equals to 9 times 4x squared is 36x squared. Then we subtracted 36x squared from this equation number 1, and found out that according to equation number 1, 2 times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. So here we define z as x squared. That is to say z equals to x squared according to our definition. So if z equals to x squared, it means that z squared equals to x to the power of 4. Therefore, this expression will be equal in total to 2z squared. So here we have 2z squared, and minus 122x squared will be equal to minus 122z, because z equals to x squared, plus 985 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So those are the three coefficients of our specific quadratic equation. So we put the data inside the formula for x, and found out the value of the values of z, because x equals to z here. So we found out that z equals to minus b, b equals to minus 122, therefore minus b is minus 122, that is plus 122, plus minus b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is minus 7,880, all divided by 2a. A is 2, so 2 times 2, that is 4. So we found out that z equals to 122 plus minus, and 14,884 minus 7,880 is 7,004 divided by 4. So here we found out that z equals to 122 plus minus the square root of 7,004 is 83.6899 divided by 4. So here we have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 divided by 4. 122 plus 83.6899 is 205.6899. So if we divide it by 4, we get that z equals to 51.422475. So we actually found out that z, that is equal to x squared according to our definition, equals to 51.422475. 422,475. So we took a root out of this number in order to get the value of x, because this number equals to x squared. So the square root of this number is 7.17 units. So we found out that x equals to 7.17 units, and it is impossible that AB that is equal to x equals to 7.17 units. I will explain why. Because here we have the right triangle APM. In the right triangle APM, the hypotenuse AP equals to 5 units, and the hypotenuse is the biggest side in any triangle, in a right triangle, and especially triangle APM. So AP that is equal to 5, the hypotenuse is greater than AM. So if AP is greater than AM, let alone that is greater than AB, that is equal to x. Okay, so AP is greater than AB, that is equal to x. So in the right triangle APM, the hypotenuse AP that is equal to 5 units is greater than AB that is equal to x. So from this inequality, we will get that x is less than 5 units. But we just right now found out that x is equals to 7.17, that is greater than 5 units. So we have a contradiction here. X cannot be simultaneously less than 5 units and also greater than 5 units. So due to the contradiction, we cancel this possibility and we left only with the second possibility, that z equals to 122 minus 83.6899 over 4. So 122 minus 83.6899 is 38.3103. And if we divide it by 4, we'll get that z equals to 9.5775. But what is z? Z is x. According to our definition, z equals to x squared. And we just found out that z equals to 9.5775. And the area of square ABCD is x squared. So we have found out that the area of triangle ABC, the area of square ABCD that is equal to x squared, it is equal to z, that is equal to 9.5775 units. We took a root out of this number in order to verify that x is not greater than the hypotenuse AP. Indeed, the square root of 9.5775 is 3.09. That is less than the hypotenuse that is equal to 5 units. So the answer to the question is that the area of square ABCD equals to 9.5775 square units. We finished with the first question, then I presented to you the second question. Here in the drawing, we have a right triangle ABC. Angle ABC equals to 90 degrees. Inside the right triangle we have a circle. Inside the circle we have triangle DOE, and we are looking for the size of this angle theta. It's given us the question that line segment AD equals to line segment EC, and line segment DE is twice as long as AD, line segment DE also is twice as long as AC. So actually, and we have here, it is given us the question that AD equals to EC equals to DE over 2. So we defined DE as 2A, and according to what is given as the question, we know that AD equals to EC equals to DE over 2. And according to our definition, DE equals to 2A. So we substitute DE by 2A, and we got here 2A over 2 is 8. So in conclusion, we found out that from this long equation, we get that AD equals to EC equals to A. AD equals to EC equals to A. So AD equals to A, and EC is also equals to A. Then I presented to you rule number 4. We implemented rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. We have the perpendicular OM from the center of the circle, that is point O, to chord CD. According to rule number 4, the perpendicular OM bisects chord CD. That is to say, CM equals to MD, and Cm equals to Cd over 2, and Md is also equals to Cd over 2 because chord CD has been bisected into two halves, each half equals to CD over 2. Can implement rule number 4 in our drawing. Why? Because in our drawing we have from the center of the circle we draw perpendicular to chord DE, and according to rule number 4 the perpendicular OT bisects chord DE. That is to say dt equals to TE. Here dt equals to TE according to rule number 4, and the chord has been bisected into two halves, each half equals to dE over 2. So TE equals to D over 2 and dt also equals to D over 2. So we substitute dE by 2a, and we got that 2a over 2 is 2. 2a over 2 is a. So in conclusion, we found out that dt equals to TE equals to a. dt equals to T equals to a. That is to say, dt equals to a and TE is also equals to a. Okay, then we defined the touching point of tangent AB with this circle as M. We define the point of tangency of tangent BC with this circle as N. Then we join points O and M together by straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle that is equal to R according to our definition. We have the radius OM that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle will be equal to 90 degrees according to rule number 1. Likewise, we join points O and N together by straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of this circle that is equal to R. And we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So actually we found out that in quadrilateral OMBN we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees. Therefore quadrilateral MOBN that has 4 right angles is a rectangle. Okay, quadrilateral MOBN is a rectangle. We also note that the opposite sides of a rectangle are equal to each other. That is to say MO equals to BN. But MO equals to R. According to what we have already found out, MO equals to R. So from this equation, R equals to MO equals to BN, we derive that BN is also equals to R. Here BN equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. But ON equals to R, according to what we have already found out. So from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. Here MB equals to R, so we actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to R. Okay, then I presented to you rule number 10, and we implemented rule number 10 in our drawing. According to rule number 10, if we have the external point P, from the external point P we have tangent PA that is tangent to this circle at point A, and we have the straight line here that intersects with this circle at points B and C. So if this is the data that has been given to us, then AP square equals to PB times PC. Again, AP square equals to PB times PC. Actually, we implemented rule number 10 in our drawing. Here, if we focus on the external point C, we have tangent CN, and we have this straight line that intersects with this circle at points E and D. Therefore, we can implement rule number 10 here. According to rule number 10, we get that CN square equals to CE times CD. Again, CN square equals to CE times CD. Again, CN square equals to CE times CD. So CN square equals to CE is A, so substitute C by A. times CD. What is the value of CD? It is very easy to see from the drawing that CD equals to A plus A plus A, that is 3A. So substitute CD by 3A, and we found out that Cn squared equals to A times 3A. So Cn squared equals to A times 3A is 3A squared. We took out of this equation and found out that Cn equals to square root of 3A squared, that is square root of 3 times A. Then we focus on the external point A. From the external point A, we have tangent AM to the circle, and we have the straight line that intersects with this circle at point D and point E also. Therefore, we can implement here rule number 10. According to rule number 10, AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again, here, AM square equals to AD times AE. AD equals to A, so we substitute AD by A. DE, what is the value of AE? The value of AE is A plus A plus A, that is 3A, so we substitute AE by 3A. So in conclusion, we found out that AM square equals to AD times AE. So AM square equals to A times 3A. A times 3A is 3A square, so in conclusion we found out that AM square equals to 3A square. We took out of this equation and found out that AM equals to square root of 3 times A. Here, AM equals to square root of 3 times A, and Cn is also equals to square root of 3 times A. Then I copied the right triangle ABC in a new page, and we actually copied the right triangle ABC in this new page, and the analyze triangle ABC. What is the value of the hypotenuse? The hypotenuse AC equals to A plus A plus A plus A, that is 4A. So AC equals to 4A. What is the value of AB? AB equals to square root of 3 times A plus R. And BC is also equals to square root of 3 times A plus R. So this is the right triangle ABC that I copied from the original drawing. So in this right triangle ABC, side AB equals to square root of 3 times A plus R, and side BC also equals to square root of 3 times A plus R. Therefore, those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So this angle is alpha, this angle must be also alpha. And this is the right angle, this angle equals to 90 degrees, therefore the rest two angles must be also equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees, that is the sum of the angles in any triangle. So the sum of those two angles is 90 degrees. So alpha plus alpha is 90 degrees. Alpha plus alpha is 2 alpha, so 2 alpha equals to 90 degrees. We divided this equation by 2 and found out that alpha equals to alpha equals to 90 degrees over 2, that is 45 degrees. So each angle here equals to 45 degrees. Then in this right triangle ABC, cosine 45 degrees equals to BC over AC. In the right triangle ABC, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R, and AC equals to 4A. And cosine 45 degrees is 1 over square root of 2. So in conclusion, we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A and found out that 4A over square root of 2 equals to square root of 3 times A plus R. Here we substituted 4 by 2 times 2 and found out here that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substitute one of the 2's by square root of 2 times square root of 2 and found out that 2 times square root of 2 times square root of 2 over square root of 2 times A equals to square root of 3 times A plus R. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and the left only is 2 times square root of 2 times a, that is equal to square root of 3 times a plus r. Here we subtracted square root of 2 times a from this equation, and we found out that 2 times square root of 2 times a minus square root of 3 times a equals to r. Here we took a as a common factor out of those two expressions. So a is a common factor. What is left from 2 times square root of 2 times a after we took limit a is a common factor? What is left is 2 times square root of 2. And what is left from square root of 3 times a after we took limit a is a common factor? What is left is actually square root of 3. So in conclusion, we found out that r equals to a times 2 times square root of 2 minus square root of 3. Then I copied the right green triangle, triangle DOT in this new page, and we analyze triangle DOT. Here point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. So this is triangle DOT that I copied from the original drawing. DT equals to A, OD equals to R, and this is angle theta, the angle that we are looking for. In this right triangle, triangle DOT, cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Cosine theta equals to dt over do. So cosine theta equals to dt. dt is a, so we substitute dt by a over do. do is r, so we substitute do by r. So in conclusion, we found out that cosine theta equals to a over r. Cosine theta equals to a over r, but we have already found out that r equals to a times 2 times square root of 2 minus square root of 3. So we substitute r by a times 2 times square root of 2 minus square root of 3. Okay, so here we have a in the numerator and a in the denominator, so a will get cancelled, and finally we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of angle theta itself. In order to find out the value of angle theta itself, we operated the opposite function of cosine, that is cosine minus 1 on the result, and in this way we got the value of theta itself. So the opposite function here is of cosine is cosine minus 1. We operated on the result, that is 1 over 2 times square root of 2 or minus square root of 3, and in this way we got the value of theta itself. The value of this expression, when we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, it gives us 24.203 degrees. So in conclusion, we found out that the size of angle theta is 24.203 degrees. Here, the size of this angle theta, is equal to 24.203 degrees. Okay, thank you very much.